Hi, my name is Gray Lovelace, and this is Technically Speaking with Source Allies. Today we're going to be covering some really cool stuff called behavior-driven development. And behavior-driven development, if you're not familiar, takes a few different forms, but really the way we're talking about it is almost as an evolution of test-driven development that focuses a lot more on your app functionality requirements instead of how your app is implemented. So really this is going to be trying to take things like your business requirements coming in and creating tests that one-to-one or many-to-one for each test or requirement, make sure that your requirements are being met by your application and trying to look at those things through a consumer of your application lens instead of the internals of your application. And it's kind of done in a pseudo unit test / integration test kind of way that is more available to us now with newer technologies over the last few years. I'm going to dig into what some of those might look like. So let's dive in and see what some of this stuff might be. So, like I say here, this is an evolution of test-driven development. It's going to focus on those app functionality requirements. And I've really broken this up, at least from my personal experience, into about 3 or 4 different tenets of what I try and make sure is happening when I'm writing these types of tests and when I'm approaching a new project or an existing project to make sure that it still meets all of those functionality requirements that we need. So this first one is going to be, like I said, that test cases represent functionality, not the implementation of your class. Oftentimes when people write unit tests, they write things at a class-based level just because that's what they're used to. And I find that ends up being really, really fragile because anytime you go to refactor, you have to end up refactoring all of your tests as well. So if you move this from service A to service B, or you move it out of the service layer and into the web layer or something along those lines, you're not only changing your logic, you're changing all of your tests to go along with it. It makes things very tightly coupled, and it makes them really fragile, and it just is not fun for anyone who's maintaining a project like that and that entire project lifecycle. So instead, we're going to consume everything as if we are a consumer of our app. I'm going to be focusing a lot here on web applications that make APIs available, but the same can be said for when you're testing the UI, the same can be said for when you're testing really any kind of consumer contract that you're making available. So we're going to take those requirements, and I'm going to outline some requirements in a second for this test app that we're going to build together, and I'm going to take those requirements and we're going to translate those into test cases that make sure we are fulfilling those requirements, and those are going to be the test cases for our entire application going forward. And make sure that we don't get in any regressions as well. The next thing is really more of a testing strategy. We want our test coverage to span all layers when possible. So when we're talking about traditional unit testing like we talked about before, a lot of the time we're really only getting good coverage at this service layer, really where a lot of our application logic lives. But that's not how apps are written now most days. We are almost always using one to multiple different frameworks to make our lives easier because we don't have to want to re-implement all of the stuff that has been done by people who are experts in that space before. Things like security, things like web layer, things like consuming different applications. Maybe you have an SDK. In this case, we're going to use Boto 3, which is an SDK for interacting with AWS services. And you don't want to have to test those specifically, but you do want to be able to test how you're using them, how you're configuring them, and then what the responses would look like. So we are going to try and take things, and instead of just really grabbing a little bit of our broker and a little bit of our web layer, we're going to cover our entire web service and broker layer, and then even a little bit of what it looks like to be a consumer of our service outside of that web layer. So as big as possible. And how we're going to achieve that is really the next one. We're going to prefer real logic over mocks. So this takes a little bit of explaining. A lot of the time when you're doing traditional unit testing, you leverage a mocking library for the majority of cases. You're saying, hey, I'm calling this other library, let's say that SDK that we talked about earlier, and I don't want to test the SDK functionality, I want to test my own functionality. And while that is a great mindset to be in when you're really trying to get down to unit level testing those very small units, in reality, it doesn't help you determine if you're meeting your requirements or not all the time. So what we want to do is opt for, instead of using those mocks that are really overriding an entire functionality, we're going to try and use real dependencies as much as possible. An example of that looks like this. Like I said, we're using the AWS, in this case we'll be working with DynamoDB, which is an AWS service, kind of a NoSQL service, a very, very simple object, like JSON object storage service, if you're not familiar. And instead of us mocking what goes into and comes out of that SDK, SDK, we're going to be testing the entire SDK and how we interact with it and how it's configured, as well as trying to use very, very similar logic to what's deployed in actual AWS, leveraging different things like local stack. So local stack is a Docker container, and I found that there are Docker containers out there to mimic most services that you're going to be interacting with on a regular basis. So we're going to stand up this local stack Docker container, say, hey, I want you to provision a Dynamo table that looks like this, and then all of our tests can just run against that Dynamo table, and I cannot tell you the amount of just peace of mind that it gives me to know that all of my tests didn't just work against what I assumed it was going to send back based on me mocking something, but instead it's calling the SDK. That SDK is interacting with local stack, and local stack is doing its logic behind the scenes and returning me versions of the objects that the actual service would return. Anytime we can get something like that looks like a real dependency, I do this with databases all the time, maybe just stand up a really quick PostgreSQL instance. You can do all of your coding to that instead of just pretending that something might be returned from a database using a mock. So real dependencies are always key if you can. These are things that used to require an entire live environment for you to test, like traditional integration tests or traditional end-to-end tests. That's not really the case anymore. We can change the paradigm of how that stuff works. And instead, we can just stand up local versions of those services in memory, and it's not going to give us a huge performance hit, and it's not going to be prohibitive for what types of machines can run these tests. It's really kind of a new world from where things used to be even just a few years ago. It's really cool. Next up, we have stub dependencies. So stub dependencies are distinct from mock dependencies in my mind in that they follow a consistent logic. So instead of saying, don't call this library, instead return this thing, and you're basically in your code saying, don't even do what I told the code to do, instead do this other thing, which is what a mocked dependency is. A stub dependency is saying, hey, I have an implementation of this service. Really, it's an implementation dependency. In this case, we're going to do this in the web layer. And instead of us saying, when I call our HTTP GET on my requests library, and I want you to return something, instead of us not even making the HTTP call, we're going to use a library that allows us to fake out the server, basically what we would be calling with the HTTP call, and return from there instead. It's distinct because we're actually getting to leverage how we're calling through HTTP instead of us just not running that code whatsoever by mocking it out instead. There's a distinction there that's a little bit nuanced, but it's really, really helpful to know that you're running all of that code instead of just overwriting parts of it with mocking. Now, all of this said, there are still some cases where you do need to mock dependencies sometimes. A situation might be like you're using an LLM. Often I will switch between stub dependencies and mock dependencies when I'm trying to write unit tests for what an LLM interaction might look like. And that is a really good case where sometimes you just can't have a real dependency. You're not going to deploy an LLM to your test cases. Maybe that changes in a few years. I don't know. But it's going to be really hard to write some deterministic test cases when you're doing something like that. All of that kind of culminates in these last two pieces here, which are tests should only really need to change when either your consumer contract changes, your API, or maybe you get new business requirements for how data that's sent in should be handled. All of that is kind of under the umbrella of consumer contract changes, and then dependency contract changes. So let's say that I've decided that instead of us storing our data in DynamoDB, we're going to store it in an RDS, or we're going to store it in some self-managed database, PostgreSQL, that we want to stand up. Great. Our tests will need to change a little bit. Not really the way our tests are executed, but some of our test setup. And I'll show you what that looks like in just a second for our current setup now. But really, that's it. If you want to go in and you want to refactor, you decided something doesn't belong in the service layer and belongs in the web layer, or vice versa, or you want to change an entire library that you're using, but you're not really calling out to something different or changing the way something calls in, great, do it. It's not going to change your tests at all because your tests are more worried about the requirements than they are about the specific implementation of all of that stuff in the middle. Okay? Now, before we dive into this, I do want to give the caveat that there are a couple of downsides to this in, comparison to how traditional unit testing is done. And that's one, traditional unit tests are super fast. You can run hundreds and hundreds in, sub-second if you write them well. Not that all of them are always written super well, but these are going to be a little bit slower. Are they slow? No. But are they a little bit slower? Definitely. We are calling live services. Sometimes we have to worry a little bit about state management in between tests, and you're going to see that here with our DynamoDB, or if you were using something like a database. Your code is not in control of everything that's going on in your tests anymore because we have some of those live services behind the scenes. So you might need to empty out a table between every test. That said, it's really not that much of a performance hit for the benefit that it gets you, which is really nice. Another big downside that I hear people talk about when looking at this is you need to understand a little bit more about the application before you can get started writing some of the tests. There are more cross concerns about what your application is doing. If I want to make a call out to a particular endpoint, then I need to know that that endpoint relies on these services to be able to return appropriately. I would say, one, you should probably make some sensible defaults in your testing config to start with, and we're going to look at what some of that looks like as well. But on the other hand, maybe that's a good thing. I've found cases where people do write tests that in very, very small situations do make sense when you're doing unit tests or at that class level. But here they don't really make sense anymore when you start looking at the larger picture of how that thing is used. Now, there are lots of reasons that could happen, but I have seen it happen before. And if they did have that higher barrier to entry for writing some of the tests, it actually might have saved us in certain cases, which would have been really nice. And the last is just that it's more complicated. It's a little bit more complicated. Once you get used to it and you start kind of embracing that test-driven development and that behavior-driven development mindset, I find it becomes a lot easier. But for people that are not used to that mindset, something like this can feel like a really large hurdle to start out, even if they know the app well. So keep those things in mind as you start to approach maybe implementing this in one of your projects or bringing it up to the teammates that you're working with. I find that the benefits outweigh those detriments 10 to 1. They're huge. It makes me feel so much more confident when I'm deploying out to production, and it makes it where I can refactor on the fly and not have to worry about spending days refactoring tests that don't add any business value. I want to add business value as quick as possible, and I want to be able to respond to changes and what that business value should be. So this is the way that I want to do that. All right, so let's dive into what we're actually going to be doing. Let's look at our app requirements. So for this app, we're going to make a Teammates API. I know I've probably done that in a couple other ones before, but everyone knows what something like this should look like. And in our case, we're not going to make a CRUD API because we're not really going to support updates or deletes. We're only really going to support creating new teammates and getting all the teammates that exist right now. Let's make a limited scope of what we're trying to implement. So we have a /teammates API endpoint that our app will support, and it supports get and post only. Great, fairly easy. That post endpoint will create a new teammate object. It's going to store it in AWS DynamoDB in our case. That could change to anything we want it to, and the test itself is not going to change. The setup might change a little bit, and of course the implementation would change, but that's fine. Our test won't really need to do a whole lot behind the scenes. The post endpoint should also support a body that has a first name, last name, and age, and then we have some validation requirements there. First name and last name must not be empty, and age must be a number between 18 and 99. Okay, that should be pretty fun. We have a get endpoint that should return an object with a list of teammates containing all created teammates, and a teammate will have the fields first name, last name, preferred name, and age. Okay, preferred name is new, so we'll read on and see where that comes from. And then the list will return alphabetically by first name, just so we can have some standardization so our consumer knows what to expect. That's kind of a weird one to sort on, but we're going to do it. And then at the end here, you can see when creating a teammate, we should consume an API at preferredname.com. I have no idea if that really exists, but we're going to say it does. And that'll give you any preferred names for the first name sent in. And then we're going to preserve that for preferred name in our preferred name field for that teammate if one did exist when it was created. Sound good? Cool. Well, now that we've done that, I'm going to give you a little bit of a tour of how I've set up this project so we know what environment we're working in. First things first, I chose Python this time. You can really do this in any language, and I've done it in Java, I've done it in Kotlin, I've done it in Node, Dino, really like those JavaScript and TypeScript frameworks, as well as Python here. So there are so many different things you can do in every language, and every language has multiple frameworks that provide tools that allow you to do these things easily now, which is really nice. So the first one, like I said, we are doing Python, and we're using Poetry as our dependency management. So you can see here what that looks like. And you can see we have things like Fast API, which is going to be our web framework that we're leveraging. Bodo 3, as well as some stubs that allow us to know the typings of objects coming back. And then we have our .env to just load some environment variables that I'll show you in a second, as well as some testing things. Our make file is just a helpful file that's going to let us do a Docker compose up and then have those containers running behind the scenes after they've determined that they are healthy, which is that wait directory right there. And then we are going to run our coverage and run our tests. Fairly simple stuff. Our Docker compose file that's going to come up is going to leverage that local stack image that I talked about earlier. So we are saying we want to grab this local stack image with this version. We have our local stack services of just DynamoDB in this case, very, very simple. And then we are setting up some just very, very simple access keys. So we have one region determined, and we are saying dummy access is our access key, and dummy secret is our secret key. And then that is going to be running on port 4566. I commented this out just because it's a cool thing to call out. A lot of these containers that run like this have some nice things built into them, and this is one of them. So if I wanted to run some AWS command line scripts when this starts up to maybe create tables or create anything you really want or do some management or printing out of what already exists, I can actually just make an SH script, a shell script to do that, and then stick it in a very particular place in our container. And it knows to go look at that and during certain lifecycle events of when the container's coming up to run those scripts for you. So that's honestly what I usually end up leveraging, but for this one, I'm just going to do that all through code. All right, our environment variables are just things that are going to make it where when our app runs, either in tests or local right now, it's going to point to local stack. This would obviously look different if you're deploying out to a real environment, but if I set all these environment variables, the SDK is automatically going to handle just directing all of our AWS traffic to our local stack container for us, which is nice. All right, here's where some of the fun stuff starts happening. If you are not super familiar with Python testing has a concept called fixtures. And fixtures are almost like dependency injection type things you can set up, and they also are how they handle running their like before each test or before each class or before each session type of setup scripts. So it kind of does both of those things for us. So I'll show what each one of these does. First off, we're just going to load our .env stuff, so we're pointing at local stack like we talked about earlier. And then we're going to make a fixture here, and so this is just called test client. Very, very easy. It's an object we can use to call the web endpoints on our app, and we don't have to worry about like pointing it to the right place. Fast API just takes care of it and provides us a way where we can call using HTTP, and we only have to give it the relative path. It'll automatically point to our app that's running behind the scenes for us when we're doing our testing. So you will see that to use a PyTest fixture in our tests later on, we will just need to say, hey, this test takes a parameter of client, and that client is a type test client, and it will automatically handle grabbing this guy and injecting it into our test for us, which is really nice. Down here, we are doing a little bit of that managing state that I talked about. So here's where some of the downsides start to show. We have our DynamoDB. This is really like a before each that we would be running. So this is doing auto use true, meaning we don't even need to say that we want to use this fixture. It's just always going to be done before every single test. And this is just going to say, hey, I want to go grab a DynamoDB client from Bodo 3, and then I want to try and delete the table teammates if it exists, and then I want to recreate it. And this is just our super quick way of saying, purge the table and have a fresh table at the start of every test that we want to run. I've done this 4 or 5 different ways. You can do it whichever way makes the most sense to you and is still performant. This one works totally fine. I would typically go through and just delete all the records, either one by one or in batches if I were managing setting up the table in that initialization script instead of setting it up in here. So you can see that our Dynamo table behind the scenes is going to be called teammates, and it's going to have an ID attribute, and that ID is going to be of type string. Dynamo has a little bit of weird syntax, but that's what that's set up to be. And then we're going to yield that DynamoDB resource so it can be used later on if we wanted to in one of our tests. We don't, but it's there if we want it. And then down here, we have some default API behaviors. We can take a look at that in a second, but really all this is saying is we have a requests mock library, which is that kind of stubbed response I talked about earlier. And we're going to say anytime someone calls out to this URL, I want it to actually call out to that URL, but it's going to get intercepted, and it's going to return the HTTP payload of name none. So our default, if someone calls out to preferred name and we don't have a match, is they're going to get back an object with name none. But if they call with a name of Benjamin or a name of Jacob, they are going to get back Ben or Jake. Fairly straightforward. This is really all the setup we have to do to make sure that when we're running our tests, it's going to behave similar to our real environment that we want to make sure we're adhering to. So let's go take a look at some of the tests that we wrote. I have things kind of half written, and we'll write some more of them together, and then we'll implement together. Here is our test file, and this is going to be all of our tests we're going to write to fulfill all those requirements we looked at in the README earlier. So the first ones are fairly straightforward. Our README said that we wanted to have a get endpoint, and we wanted that get endpoint, a get and post endpoint, and we wanted to not do anything else. So great, let's write some tests to assert that. So we're just going to pick some things like delete and put, which are other REST methods that we can call, and we're going to make sure that that returns a 405 status code, which should be method not allowed. So if I bring up my terminal here and I run make test, we should see that those should really work almost out of the box. Oh, let's go take a look at things and see what's going on here. Oh, we have some other tests that I'll get to in a second, but you can see the first two that ran just fine. So let's just say that those are done. We don't need to worry about those right now. Now we have our get endpoint. Let's take a look at our get endpoint, and we're going to see what should happen when we try and get teammates when no teammates exist. Kind of doing an empty check is always really helpful in situations like this. So I'd like to write out my tests in given when then. You don't have to, but I find it organizes thoughts a little better, especially when you're trying to match two requirements. So we're going to say, given that no teammates exist, when I call that get/teammates endpoint, the call should be successful. So we'll check the status code, and then it should return an object with an empty teammates array. And what I'm going to do, just to simplify things right now, is I'm going to comment out all those other tests that I kind of have half written right now. So if I run this, I should get that we are fully passing, because we determined those first two were working, and we can see that that last one is working as well. So let's make it fail. That's test-driven development, right? So we're going to return an object with an empty teammates array. Actually, before I do this, I should probably show you what the code looks like. We are working with our teammates.py. So in FastAPI, all you need to do is set up a FastAPI app. We're loading our .env, and then we just have a get/teammates, which returns hello world, and a post/teammates, which also returns hello world. So we have basically no logic written besides that these endpoints exist right now. Coming over here, you can see, let's fill out the rest of this test. So when no teammates exist, we call that, it should be successful, and it should return an object with an empty teammates array. Great, let's assert that. So let's assert that response.json equals an object with a teammates array that's empty. Cool. Now if I run my tests again, we should see that this starts failing, because right now we're getting back hello world. Perfect. That's exactly how test-driven development should go. Let's go implement, shall we? And in this case, let's be a little bit maliciously compliant. So let's just say we do return a teammates field, and that field is just an empty array. If I go run my tests again, we should be passing now. And we are. And honestly, that's totally fine. That requirement is fulfilled. Let's not touch it again right now. It'll start failing later, or not this test, but a future test will start failing, and we'll be able to go implement our real logic and make sure we don't get a regression from how this used to behave, because the test is already written. Back to our tests, let's go start looking at our post endpoint, shall we? So this first one, fairly straightforward. When the post teammates API is called, and called with a valid payload specifically, we expect it should be successful, and we expect the response should be empty. Some posts and create endpoints will return back the object created. In this case, we're going to say it doesn't, and that's fine. So let's go make our valid payload that we talked about before. So in this case, it's going to contain a name, and I'll just use mine for right now. Why not? It's going to be Gray. And actually, this contains a first name, not just a normal name. I apologize. We are also going to have a last name, which in my case is Lovelace. And then we are going to have an age, and that will be, let's say, 35. Why not? So that is going to be our JSON payload that we're sending in to create a teammate. Now, do we actually care that we're creating a teammate for this test? If you look at it, the answer is no. We just expect it to be successful when it comes back. And that's fine. And it should return nothing. So if I run this now, we should see that it doesn't work. And the reason it doesn't work isn't because it wasn't successful. The reason is because we are expecting it to return nothing, and instead it gave us back hello world. So let's go fix that with our implementation. Coming down here, instead of returning hello world, we are just going to pass, which in Python just means this is a valid function, but don't do anything, which right now pass our tests. Excellent, love it. Okay, back to the tests. So let's start looking at some of those validation things that we had. So we said first name must not be empty, last name must not be empty, and age must be a number between 18 and 99. This could take so many different forms in terms of implementation, and that could be at the web layer or it could be at the service layer. Lots of different things we could do. But first, let's make sure that we have tests that are covering it. So here I want to show you what leveraging something like a parameterized test would look like. So our test is just going to be that it validates, and then we're going to say when the post teammates API is called with an invalid value of some kind, then the request should return an unprocessable entity. And what I'm going to do to make this a little bit easier on us is I'm going to take this valid payload that we had before, and we're just going to take that and throw it in a variable we can use later on. So valid create teammate payload equals, I'm just going to throw that there. Now, oops. Now we can take that, throw it in our old test, and then here we can just start using it and saying destructure this whole thing. So we're kind of dumping all of the keys from that valid one into here, and then we're just going to override where we want to. So this first parameterization, you can see we're saying field and value. So field here and value here, and then we're giving it what we want those values to be. So we're just going to start overriding different fields with incorrect or invalid values and making sure that we're getting back that these are unprocessable entities. We could get a little bit more detailed and check what the error messages are on each one of these. For right now, just for sake of brevity, I'm going to show you what doing this in a parameterized test would look like instead. So we are checking that first name of none should return 422. So let's go down here. We're going to take our field that was sent in. So we're going to take first name, and we're basically going to overwrite first name with the value that we set up in our parameterized test. So this will be everything in our valid payload that we have, and then we're just going to overwrite first name because this is defined after with none in this case based on these values. So let's take a look at what happens. Excellent, we failed. And you can even see exactly what it sent in, first name and none. So let's go in and let's start implementing this and see if we can get it to work, shall we? So in create teammate, the way that we do post bodies in Fast API is actually pretty cool. We are going to create a class that's going to represent our post body. So I'm going to call this create teammate request. And then this is going to inherit from something called base model, which is from Pydantic. And Pydantic is a pretty cool Python library that helps with object validation. So if we come down here, we can start saying what this should look like. So let's make our first name here, and this should be a string. Great. If I run this now, this might even work, because a string does not say string or none, it's just string. Okay, it looks like that is not the case. Oh, you know what we forgot to do, and this is a really good way to make sure that we are checking our web layer, because you could configure this stuff incorrectly, and if you called the method directly, you'd still be fine, but your web layer is not like parsing it out the way you were expecting it to. I do need to come down here and actually add this as a parameter. So now it'll see that there's a base model object that's one of the parameters and assume that is the body and try and deserialize it from JSON into our body for us. Perfect. So now we pass. That's great. Let's go implement our next thing. So if I go back into test teammates, we also said blank strings shouldn't work. So I'm going to add a new one, and we're just going to make this a blank string. And if I go run my tests again, we should see that first name none still runs and passes, but first name blank doesn't pass anymore. Great, let's go implement and see what that looks like. The nice thing about this being a validation library is that we can add some additional stuff to it. So we're going to grab field from Pydantic, and then we're just going to say we want this to have a min length of 1. So this is going to be a string that has at least something in it for us, right? Now if we run our test, does it work? It does. Great. So a lot of this feels like very traditional test-driven development, which is good. It should. But it just happens to be that we are using this as a web consumer in our tests instead of something checking that this specific method in this specific class works for us. Let's really quick go implement the rest of these. So what this would look like is if I go back to test teammates, we're going to grab both of these and we're going to do them with last name instead. Okay, these should not work. Excellent, and then we're going to go back to teammates and we're going to implement it by just adding a last name that looks very, very similar. Excellent, and then the last one is just age. So if we come in here and we throw age in and we give it an invalid value. So let's throw a negative on there, and then I'm just going to do all these at the same time. We'll throw a 0. I think we said someone had to be at least 18, so let's throw a 17 on there, and they had to be at most 99, so let's throw 100 on there as well. All of these should be invalid values for us that return a 422. We should see all of these fail. Great. Let's go implement. So here, we're going to add an age. That age is going to be an integer of some kind. And then we're going to give it field. And instead of min length, we are going to leverage greater than and less than here. So we expect this to be greater than 0, or no, greater than 17. That's right. And then we are expecting less than 100. Oh, we're failing. Okay, so it looks like we're failing with 17 and 100. So there's a strong possibility that I configured this incorrectly, which is kind of what I wanted to test. So if I go back, these are probably inclusive, which means I should move this to 18 and move this to 99. And let's see what happens when I do that. Perfect. Now everything works the way we would expect. That's something that could really easily have been done incorrectly, were we not testing the entire chain of what we were doing, including the HTTP layer and how we have it set up to validate for us. Okay, now going back to our tests, we only have a couple more things to check. So we are going to check that our kind of entire life cycle of creating a teammate works appropriately. So we are going to test get teammates. We're going to say given 2 teammates exist, so we're going to call the create endpoint to do this. The way I like to approach this, we could go insert stuff directly into DynamoDB for some of these if we wanted to. I don't really love it because, again, it's an implementation detail. The way I like to think about this is if I deployed this app somewhere and I said, hey, I want you to go test it, you would need to go and you would need to consume it through the API, and you would need to set up test cases through that API to make sure that it works the way you would expect. So if I call this endpoint twice to create teammates, and then I call the get endpoint, I should see those 2 teammates and they should look how I expect. That's how the test should be written. There are, again, benefits and drawbacks to doing it this way, but I have found that that typically ends up being the way I like to write these types of things because it is decoupled from the implementation more. So we're going to say given 2 teammates exist, so let's go ahead and write that out. We're going to go grab where we're posting a valid teammate payload like we have up here. We're not even going to use that response, so let's get rid of that. And instead of using this pre-created payload, let's make a new one. And I'm going to copy it from what we have here. Okay, and then if you look a little bit ahead, you should see that we're going to check that they have the appropriate values and that they're sorted by first name. So just to make things hard, I'm going to give it another one that happens before this that should be later on in the response. So let's just say that this is John Doe. So here, what we should expect coming back is that Gray comes before John alphabetically, so Gray should always be the first response in this teammates array we get back, and John should always be the second one. So that's how we're going to write our assertions. Let's go call the get teammates API so we can go copy our code from where we did that up here. Really easy stuff. And then down here, we see that the call should return an object with the teammates array containing both created teammates. Perfect. So let's just say teammates equals response.json. And then this response.json should contain a teammates array like we talked about before. So this is how you access that in a dictionary. And then we can say assert that the length of teammates equals 2. Perfect. And then down here, they should have those appropriate values that we talked about. So we are going to grab each one and start doing things with them. So we are going to assert that teammates 0, so this should be the first one that comes back, which should be gray in this case. And we're going to say the name, or first name, excuse me, equals gray. And since we do want to check that we're getting all of the values that we want, I'm going to copy this a couple times. I'll throw last name in there. I'll throw age in there. And then we did say that in our requirements, we expect a preferred name to come back as well. There we go. So Gray, Lovelace, preferred name of none in this case, and an age of 35. And then here, we're going to, why not, change his age a little bit. And then we also expect there to be an ID, which we didn't call out earlier, but there should be one. So we're going to do the same thing we have here. Say an ID should be there, and then just say is not none. Perfect. So that should say that this persists exactly the way we expect it to, and all of that gets mapped back and comes from the get endpoint the way we would expect it to. So I'm going to copy all of that and throw it here for John as well. So John Doe, preferred name of none as well, and then an age of 25. Excellent. Now, I would expect this to fail. We don't have any logic that's doing this for us. Great. So we asserted that we have 0 teammates coming back instead of the 2 expected. So let's go fix it. Let's go to teammates.py, and we are going to set up how our Dynamo works. So let's go grab DynamoDB. That is importing the one from our tests. We definitely don't want that. So DynamoDB is going to equal boto3.resource, and we're going to pass it in DynamoDB. Pretty simple stuff there. Again, let's import Boto3. Great, and then this should actually be getting what this is back for us, that DynamoDB service resource. That's where our Boto3 stubs came in to help us with a little bit of that typing in IntelliSense. So now that we have this, let's go ahead and make our table resource. So this is going to be the teammates table. And you would probably manage all this stuff in other files. You don't want all this to be a web layer concern. This would be more in like a broker just for AWS resources or just for Dynamo if you wanted to. That would really be the arbiter of what is the teammates table. But I'm going to say dynamodb.table and give it our table name. And in this case, our table name was teammates. Cool. So now we have this resource that we can use to start persisting things and reading things. So let's come down to our create teammate, and we are going to say DynamoDB, or our table that we have, .put item. And this is going to take an item in, and then we're going to give it the item we want to persist. So you might think, hey, I have most of the stuff I want from here in my request, so I will just give it my request dictionary, which is a thing you can do in Python. This is not going to work, but that might be something you want to do, and our tests will obviously catch that for us, which is a great part about writing tests first. So that doesn't work as we would expect. It doesn't pass the validation of our put item operation, which is another great reason why running against the actual local stack DynamoDB is much preferred to if I had mocked this and just sent this in and said it gives me back what I'm expecting. There's no way that this would have been caught. So let's go back to our implementation and let's fix it. In this case, it was saying that, hey, I did not get some of the things that I was expecting to get, one of them being ID. So let's go ahead and destructure what we got back from our request object. And in this case, because Pydantic has a built-in method for it, we will call model.dump. And that gives us the dictionary that we want. So we're destructuring everything that was sent into the request. And then we're also going to add in that ID that we were talking about before. So we give it an ID, and in this case, we will say something like import, from UUID, import UUID4, which is a way you can make UUIDs. And then we're going to want to turn this into a string after we make it. So string UUID4, and this is just going to generate a new ID for us. Perfect. Now, I would expect this to persist, but we're still not going to work very well. And that's because we're still getting back 0 teammates. That's interesting. It's because we're leveraging both our get and our post APIs here. So even though I've done the work here to persist my teammate, and there's still a couple bugs with it, which we'll find in a second, I am not returning those teammates yet. So let's go fix that. We need to atone for our sins of just hard coding this being an empty array coming back before when we were doing our test empty. So let's go here and let's go get the teammates we would expect to return. So teammates equals, and we'll grab our teammates table. And we're going to call scan in this case. That's not something you would normally do because scanning is going to get everything from the table and you don't want to do that in a production environment, but for brevity, that's what we're doing here. Once we get those items back, we actually need to unwrap this and go grab items from it. And this will give us our teammates we're expecting. So let's go here and let's say teammates. Cool. Let's check. All right, we failed. Now, you see here that it's saying assert John equals Gray, and that's because our things are coming back in the wrong order. They're coming back in the order they were made instead of the alphabetical order that we expect them to come back in based on first name. So let's fix that as well. And I should be able to do something really simple like teammates.sort. I would prefer not to do something that's mutable, but that's the way Python is set up and it likes it this way. So I'm going to say key equals lambda of an item. And then we're going to sort based on item first name, just like we talked about in the requirements. Now this, it doesn't know is always a string, so let's let it know that it is always a string, or at least coerce it to that for it. And let's run our stuff again and see what happens. Perfect. Still failed, but for a different reason. And in this case, we had things in the right order, but you can see that when we tried to get out preferred name, it didn't work. So we were checking if preferred name equals none. Not only was preferred name not none, preferred name just didn't exist on the dictionary at all, so we failed to compare it. This is not great. So let's go add preferred name of none so we can pass this requirement for right now when we're making our teammates. Come down here, same thing we did with ID, where you're just going to make a preferred name. And right now, the only thing we need to do is set it to none because that's what our requirements in our test cases expect. Excellent. We're passing. We have one more test to go until we have all of our requirements covered, which is really nice. So let's go take a look at what that last one was again. Going back to the README, you can see it's this one. So when I'm creating a teammate, I should consume an API at preferredname.com, and it'll give me any preferred names for the first name sent in, and I preserve that as preferred name if it exists for the teammate I'm creating at the time. So let's go write a test for that. So test create teammate persist preferred name. We still have our client coming in, so we're going to say given a name that'll return a preferred name from the preferred names API. And if we go look back at our conf test setup, basically the defaults of the environment that we set up before, you can see that the name Benjamin and the name Jacob both are expected to return a preferred name. But if I send back or send anything else, it doesn't. So we are going to opt for Benjamin in this case. So here, we're going to say that that happens behind the scenes. It's already taken care of in our test conf. We're going to call post with that teammate, given that name. So I'm going to grab this here. And we're just going to change this to Benjamin Doe. Great. When get teammates is called, so let's go ahead and do that as well. Then the call returns an object with the newly created teammate, as expected, with the given name and preferred name. So then let's go grab the one we got out of here. So resp, we need .json teammates. And we're just going to grab the first record out of that. And this is going to be our teammate equals. Then we're just going to do our assertions like we would expect before. I'm going to grab all of these and leverage what we can. So we're just going to delete that part. So that's still valid. This guy is going to change to Benjamin. Last name's going to stay Doe. Our age is going to be 35. Why not? A lot of these times, these values that don't matter, I would replace with a random value generator like Faker is one in Python, or you have lots of other ones like in JavaScript and Java that you can use. But in our case, we are just going to hard code them for now, so it's simple. And here we are expecting that this is going to give back Ben, just like we see right here from the default behavior of what our web API should be doing, or a dependent API that we're working on. So let's go take a look and see if this fails. And I would expect it to, because we haven't written any logic that's going to perform this for us, right? And you can see it fails exactly where we would expect. Exert none equals bin. So let's go implement that, and then we really should be done because we've made tests for all of our different requirements that we have. So back in our teammates.py, down here, let's go check and see. Let's make a quick method to consume that, that API we talked about before. So we're going to say def get preferred name. This is going to take in a name of some kind, a first name specifically. Let's be good stewards here and name our variable. It's going to be a string. And then this is going to make a requests call out based on that first name. So we are going to say requests, which is built in, or no, not built in. We had to bring that in. So requests.get, because this is a get call, and we're going to give it the URL, which if I just go grab it from here, it's going to make our lives a little bit easier. And then we're going to give it a query, so some query parameters, which in our case is called params, and we give it a dictionary. And it's expecting a name, and we are going to give it the name that was sent in here. So first name, like that. This should give us back a response object. And if we go look at what our response object should look like, and this is something you would do by looking at what this API actually does through its API docs, you can see that it returns an object with a name inside. So it returns a JSON object or a dictionary in Python in this case. So once we get this back, we can just say, let's do it this way. We will return resp name. And it already handles, resp.json name. And it already handles setting it to none if we don't have a match there, so we don't have to do anything on our side to make that happen. So this will either get back none if one doesn't exist, or it'll get back the name we're expecting if it does exist. So we just take this, throw it here, and then we pass in our request dot first name. Awesome. All of our tests pass. All of our requirements have tests that ensure that those requirements are met. Really, this is doing everything I want it to do. So the only things you need to do to make sure everything works now is make sure that it's configured correctly for your other environments as you go through your different staging, dev, test, and production environments. But yeah, this is how I have started setting up most of my projects going forward, and how I know a lot of other people at Source have started setting up their projects, just because it gives you so much refactor freedom, and it makes sure that the actual business value your app is supposed to be, providing is being provided regardless of how it's implemented. It's really freeing once you start embracing that test-driven and test-first mentality and those requirements feeding into those tests that you're creating. Thanks for watching, and if you want to know anything else about behavior-driven development or test-driven development or how we do work here at Source Allies, please comment down below, and we would love to connect with you. I'll see you next time.